This is our very first screencastify, which is super exciting. So just picture me in all of my beauty and glory, standing in front of the classroom, chatting with you guys, and getting started. So of course, we are going to start with a little bell ringer. Before we get into that, I just want you to know that because this is our first time doing this kind of thing, do the best you can. What's awesome is you can pause the video and rewind and rewatch things, which is great. And then tonight's homework, or today's work for the remainder of class, will be your completion of worksheet number 2, which is all linked on our assignment sheet and on Google Classroom. So just do the best you can, and then I will pop in tomorrow at the start of class to see if you have any questions. And if you don't, then you'll just keep moving on. So of course, we got to start with a little bell ringer. You've got 2 lines here, 3x plus 10y equals 60. And the second one is y equals kx minus 13. You know that these lines are parallel, and so I want you to solve for k. So go ahead and pause the video right now because the next slide is going to have the answer. So pause the video. All right, so we are back, and I wanted to give you the solution. So what you got to do is you got to get this first equation into y equals mx plus b form, so you can have some idea of what our slope is. And right here, you see that our slope is going to be negative 3/10 x plus 60. Plus 6. Divide everything by 10. And so you know that if the slope of this guy is negative 3/10, then the slope of this one, which is our k, also has to be negative 3/10. Did you get it right? Of course you did. You're so smart. All right. So we are now starting using distance, slope, and midpoint. So everything we practiced yesterday for Unit 7, we are now going to use in proofs. So if you think about it, when on earth would we use distance, slope, and midpoint in proofs? There's a really cool TED Ed video. I'll link to it in our assignment sheet. If you have a second, go ahead and watch it. It's about 5 or 7 minutes. And it's really cool about coordinate geometry and why we use certain algorithms in order to draw shapes, which is really cool. And they use it all the time in animation, which is awesome. So in terms of the stuff that we know, the distance, slope, and midpoint, I want to just do a quick throwback. So go ahead and pause the video again, and I want you to answer these 3 questions. So given that A is 2, 6 and B is negative 5, 10, I want you to find the length of AB, that red one, the slope of AB, and then the midpoint of AB. So pause the video and do it. All right. Did you get these answers? Woo woo! You're brilliant. Awesome. So remind me, if 2 lines are perpendicular, what do we know about them? So we know that their slopes are opposite reciprocals. So like one line would be like this and one line would be like this. They meet at a 90-degree angle, right? Which we know. And we know that if the slope of 1 is 2/3, the slope of the line perpendicular would be negative 3/2. One important thing that we're going to use all the time is if we multiply these 2 slopes together, what do we get? So 2/3 times negative 3/2 is negative 6/6, which is negative 1. And that is true for any perpendicular slopes. If I had a slope of 1/10 and the line perpendicular to it would be negative 10, if I multiply the 2 of those together, I get negative 10/10, which is negative 1. Awesome. So no matter what, if I have 2 lines that are perpendicular, their slopes are going to be opposite reciprocals, and the product of their slopes is going to be negative 1. So all the tools that we have right now in our tool belt are this. So this is in terms of like what we have for coordinate geometry. So we've got distance, we've got slope, and we've got midpoint. And we also sort of added in like the perpendicular lines their slopes are the product is -1. So that's one thing that we can sort of keep in our tool belt, but that goes along with slope. So if you think about it, distance tells us how long certain lengths are. Slope tells us how much they rise and run, sort of the tilt of those lines. And the midpoint is the point that cuts those line segments in half. So if we think about all the stuff we know about different shapes, we know that we can use distance, slope, and midpoint to tell us information about shapes. So for example, if I give you this question, and I said, what can you tell me about triangle ABC? Well, if we think about distance, slope, and midpoint, well, slope wouldn't really help us here. I mean, I don't see that things are the same slopes. They don't look like they're going to be opposite reciprocals. They don't look perpendicular. Midpoint might be important, but distance actually could tell us something. So we know that we've classified triangles based off of the lengths of their sides. So if I did the distance formula 3 times, and I'll pause here if you want to pause it and do the distance formula out. But if I did the distance formula 3 times, I wind up getting that this equals the square root of 106. This guy also equals the square root of 106. And this little puppy is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units long. Awesome. So, what do you know about this triangle? Well, I know that it's going to be isosceles. You've just proven that it's isosceles because two side lengths are congruent to each other. All right, so now if I tell you that this quadrilateral is a rectangle, we have a lot of information here. So we know it's going to be a parallelogram. So we know the opposite sides are parallel. We know the opposite sides are congruent to each other. Remember all this? We know that the opposite angles are congruent. We know that the same side angles are supplementary to each other. But one thing that's really important about a rectangle is that all of the angles are 90 degrees. So remember this back from before spring break. So if I asked you to figure out using the distance formula, what could you tell me about this rectangle? Well, something really important is that this side length, if I did the distance formula, this side length winds up being 10. This guy, using the distance formula, is also 10. And these are both 5. I know now that it's a rectangle and not a square, for example, or a rhombus because I've proven that my opposite sides are congruent to each other, but they're not all congruent. All 4 of them are not congruent to each other, if that makes sense. Another way you can use the distance is with the diagonals. So something really important about a rhombus, or I'm sorry, about a rectangle, remember, one of the properties is that the diagonals are congruent. So if you did the distance formula again, you would find that the diagonals are also congruent to each other. All right, same shape, same rectangle. And now what do we know about the slope? Well, we talked about this and we said in a rectangle, one of the most important properties is that all of the angles are 90 degrees. So let's prove that. And if I found the slope, let's say, of BA, well, the slope of BA is -3/4. That's change in Y over change in X. And the slope of AD is 4/3. Ding, ding, ding. Amazing, amazing. See how they are opposite reciprocals? Also, if I multiply them together, what's the product of these guys? The product is -1. Awesome. And then last but not least, our little midpoint. So the midpoint here actually isn't that exciting in a rectangle. The property is still the same. Remember, the midpoint tells us the middle of what a line segment is. So if I know that the diagonals bisect each other, then it means that the midpoint of BD, blue is not the best color. There we go, I'll do green. The midpoint of BD, whatever that is going to be the same as the midpoint of CA. So if you pause this video right now and find the midpoint of CA and then find the midpoint of BD, when you come back, you should tell me that you got the exact same thing for both. All right, so the midpoint that I got was 1 comma 2.5. Did you get the same? Ah, amazing. I think my drawing is a little off. We can just like make the dot bigger. Perfect. Excellent. All right. So sort of in general here. So I just like gave you a shape and you kind of proved things that I told you to prove. But here in general, if I asked you to prove that something was a parallelogram, remember we had those 5 ways that you could prove that something's a parallelogram. Opposite sides are parallel, opposite sides are congruent, one pair of sides are both parallel and congruent. You can prove that what do we have? The opposite angles are congruent and that the diagonals bisect each other, right? So if I want to prove that the opposite sides are parallel, the tool that I would use there is the slope. Look at that technology. Amazing, right? And if I want to prove that both pairs of opposite sides are congruent to each other, boom, I'd use the distance. And then if I want to prove that the opposite angles are congruent, that's actually kind of tricky. So we're not going to be doing that. Don't worry. We'll do it on particular kinds of parallelograms, but not parallelograms in general. And the midpoint we could use, just like we did before, to prove that the diagonals bisect each other. So I want you to pause the video right now, and I want you to think about which of these tools, or more than one, would you use to prove that something is a rectangle, something is a rhombus, something is a square, or something is a right triangle. All right, we're back. So for a rectangle, remember the important thing about a rectangle is that the consecutive sides are perpendicular to each other. If I know that a rectangle is a parallelogram, if I've used one of these tools already, then I know that I only have to figure out that this side and this side are perpendicular to each other. Once I know that, once I've proven that one angle is 90 degrees, then remember how you would know that all 4 angles are 90 degrees if I know it's a parallelogram. A rhombus, same thing. So I can use the distance formula 4 times, and I can find that this guy and this guy and this guy and this guy are all the same distance. Or if you know already that this rhombus is a parallelogram, then you could figure out that this guy, like consecutive sides, are congruent to each other. And once you know that consecutive sides are congruent to each other, then you would know that everything's congruent to each other. A square, remember, a square is super special. So a square is not only just a parallelogram, but a square has opposite sides. I'm sorry, all 4 sides that are congruent to each other. So that would be the distance formula there. And then we would also use the slope the same way we'd use a rectangle in order to prove that something's a rectangle. And then last but not least, proving that something is a right triangle. Remember, the definition of a right triangle is just a triangle that has a 90-degree angle in it. So if we're thinking about distance, slope, or midpoint, you could use the distance formula and do like the Pythagorean theorem, but that's a real bear, honestly. So it's much easier to find the slope of this line and the slope of this line. And if you know that they're perpendicular to each other, boom, you've got yourself a right triangle. I know that this is kind of quick, but I want to make sure that you kind of see everything in one. This is a really helpful slide, and I think if you can keep coming back to this, it'll help you a lot with the worksheets. So let's do some examples of problems. So if I wanted to prove that this triangle is a right triangle, well, I know, remember, if I'm proving that something is a right triangle, I'm going to use slope. So all you have to do here is figure out what the slope of RS is. So the slope of RS is 6/5. The slope of ST is 5/-6. And the slope, just to be certain, the slope of RT is not going to be the same thing. So it's really important that you feel comfortable with finding these slopes. And I think it's kind of cool that they wind up figuring out and becoming opposite reciprocals. So the slope of RT winds up being 12/17, negative 12/17. And so I've got this guy, and they're opposite reciprocals of each other. So then I know that that it's going to be a right triangle, and my right angle is going to be angle S. All right, next problem. So if I give you 4 coordinate points and I want you to prove that something is a rectangle, this is what we just talked about on the previous slide. So if I know it's a rectangle, I can use the slope and figure out that I've got a right angle right there. One cool one is this guy. So let's say we know that this triangle is isosceles and I want to drop a tude. So I want to drop a tude from this vertex, boom, all the way to the opposite side. So what do we know about what that altitude does in an isosceles triangle? You can pause it right here and answer this question yourself. Great. So remember, we know that the altitude bisects the opposite side. So if the altitude bisects the opposite side, it means that it goes through the midpoint. So we can find the midpoint of this opposite side, and we know that that's where the altitude crosses. And then one last problem before I let you guys go. This is a crazy one. So here are 3 coordinate points, 5, 2, 3, -6, and then 0, -1. I want to show that that 0, -1 is on the perpendicular bisector of AB. What? All right, so let's sketch this guy out. So if I plot 5, 2 right here and 3, -6, I'm just estimating. So I've got 5, 2 and 3, -6 here. So here is a B, and I've got this line going. Oh my gosh, that's terrible. I'm not going to do that. All right. We've got this line going straight through it. I want to prove that 0, -1 right here, point P, is on the perpendicular bisector of this guy, the perpendicular bisector. So what does that mean? Well, if something is perpendicular to AB, then it means that the slopes are opposite reciprocal. So first we want to find the slope of AB. So the slope of AB is 2 minus -6, and the slope of, 2 -6, and then 5 minus 3. So I get 8 over 2. So the slope of AB is 4, or 4 over 1. So I know that the slope of my perpendicular bisector, my slope is going to be -1/4. And so that's the perpendicular part. But the bisecting part, that means it's going to be going through the midpoint. So I need to figure out now what the midpoint is between A and B. So here is my midpoint. So my midpoint, remember, is the average of my x's. So 5 plus 3 is 8 divided by 2. And the average of my y's, so 2 minus 6, so -4 divided by 2. So I get 4, -2. Sort of. 4, -2 as my midpoint. So my midpoint is 4, -2. So how can I prove that P is on that perpendicular bisector? I'd have to kind of switch up P here. Yeah. How can I prove that? So you essentially know that PM, let's call it, or let's call my midpoint C, maybe, my midpoint C. I want to prove that PC, that slope of PC, is the opposite reciprocal to the slope of AB. So here is 0, -1. So if I did -1 minus -2 over 0 minus 4, oh, lo and behold, look at our slopes. The slope of AB is 4. The slope of PC is -1/4. You have just proven that P is on the perpendicular bisector of AB, and you're done. So I know this is a little long, but there's a lot of great information on here. And really the best thing you can do is just pop into that worksheet. Do the best you can on that. There are a couple tricky ones, but for the most part, they're pretty straightforward. And then we'll get into better stuff using these in the next couple days. All right. Thanks so much, guys. I'll talk to you soon.